I am considering right now in order to calculate the safety stock based on empirical data means like this is the data set. So I am considering the example right now. The lead time is constant, but the demand is in a variable form. So as you can see from this data, it is indicating a manufacturer weekly demand for the item with the lead time is constant, which is 1 week. So they have given us the item cost, or which means the product cost. So it is also indicating the inventory carrying rate, which is 20%. So based on this, we can easily calculate carrying cost per unit, which is going to be zero point 0.2, which is interest rate, okay, inventory rate, which is 20% multiplied by the product cost, which is 50. So based on that, we can calculate the carrying cost, okay. Further, it is indicating determine the safety stock level as well as the carrying cost if the manufacturer desire the service level 85% as well as 95%. So in order to calculate this safety stock, what we will do, so we have collected the historical data, which is a weekly demand, and when we have collected the data, we found that two times the weekly demand was between 1 to 50. So four times the weekly demand was between 50 to 100. Seven times the weekly demand was 100 to 150. Up to there is a three times when the weekly demand was 450 to 500, right? So using this data, okay, we have written down again based on the frequency. So based on the frequency, we have calculated the cumulative frequency. So how we can calculate the first frequency would be written as it is. So this 2 plus 4 is going to be 6. 6 plus 7 is going to be 13. 13 plus 8 is going to be 21, and so on. Okay. And then based on this cumulative frequency, we can calculate the cumulative probability. So 2 divided by sum of frequency, which is 60, then 6 divided by 60, then 13 divided by 60, then 21 divided by 60. So we are getting the cumulative probability, right? Now, what we will do, we are going to draw this weekly demand as well as the cumulative percentage. Okay, so this is the quantity, okay, which is basically the weekly demand, and this is basically the cumulative probability, or you can say the service level from 0 to 100%, which is 1. And how we are going to do the weekly demand, it is always from the upper class value, which means 50 to 500. Okay, so we have on this one, and then this line is basically indicating the cumulative probability, which means against 50 we have the cumulative probability 3%, against 100 we have the cumulative probability 10%, against 150 we have the cumulative probability 22%. So these dots are indicating those percentages, right? So the question was, we would like to find out the safety stock against the service level of 85% first. So what we will do, we will find out the percentile against 85. So what's the percentile? So it is indicating against what value at least 85% of the customer's demand we will fulfill. Okay. So what we will do in order to find out the percentile of 85, so against this cumulative probability, which is 85 percentage over here, it's a service level. And if we draw this dotted line and go down way, so it is indicating the 390 over here approximately. Okay, so that means, so at least 85% customer demand is going to be fulfilled, okay, when the quantity is going to be 390. Okay, same is the case. We can find out the percentile against the 95%. So this is 95%, and then if we draw this one, which is 450. So in order to calculate the safety stock, what we will do, we will subtract this value from the average demand. And how we can calculate the average demand? That is going to be against the 50th percentile, which is the average point, which is 50th, which is 250. So 390 minus 250 is going to be the safety stock against 85% service level. Okay, whereas 450 minus 250, that is going to be 200 against the 95% percentage of the service level. So that means if you would like to satisfy the 95% of your customers, okay, then your safety stock in this particular data case so should be 200. If you would like that the service level should be 85%, so then the safety stock should be 140. And then based on the data we can calculate the carrying cost. Okay, so 140 multiplied by carrying cost per unit, so this is carrying cost per unit multiplied by the safety stock, same is the case against the 95%. Now let's discuss the second scenario when the lead time is in a variable form. Now we are assuming that the demand is constant, but the lead time is in a variable form. So the same concept we will use. So as you can see over here, so there is a 2 time when the lead time was 1 day. There is a 3 times when the lead time was a 2 days. So basically we have collected the historical data, and based on that data, we would like that the service level should be 85%. Okay, okay, now similar approach we are going to adopt. So this is the lead time, we have the frequency, we are calculating the cumulative frequency, and then based on that we are calculating the cumulative probability, and then we are drawing the graph. So once again on x-axis we will take the lead times, on y-axis we will take the cumulative probability which is indicating the service level, and then we are going to, which is from 0 to 1, and then using this line we can draw the cumulative probability, right? So against the 85%, so what's the lead time? That is the 7 days. Okay, against 85%, we have 7 days lead time. And then in order to calculate the safety stock, so the average is 4.7 days. So that means 7 minus 4 point this one, this is indicating the 2.3 days. So that means the safety stock should be maintained to reach the service level 85% should be equal to 2.3 days inventory.